Let's look at these equations. Let's scrutinize them a little. Let's get some feeling for it, rather than accepting them as being dumb equations. Let's first take the case that M2 equals M1, and I'll call that M. Notice that A becomes 0, and notice if you substitute for M1 and M2 M here, that you get 2M, you get mg. So T becomes mg. That is utterly obvious. If M1 and M2 are the same, nothing is going to happen. They're going to sit there, the acceleration will be 0, and the tension on both sides, which is always the same, we argue that, is going to be mg. Clear. Now we're going to make it more interesting. Suppose we make M2 much, much larger than M1, and in a limiting case, we even go with M1 to 0. Let's do that. What you see now, if M1 goes to 0, this goes away, this goes away, A goes to G, and T goes to 0. If M1 is 0, T goes to 0. That is obvious, because if I make M1 0, M2 goes into free fall. And if M2 goes into free fall, its weight is 0, and so the tension is 0, and that's exactly what you see. And you see that the acceleration of that object is g, which it better be, because it's in free fall. So you see, this makes sense. This is exactly consistent with your intuition. And if you wanted to make M1 much, much larger than M2, and you take the limiting case for M2 goes to 0, you'll find again that A goes to G, and that T goes to 0, except that now the acceleration is not this way, but now the acceleration is this way, and now this object will go into free fall. And therefore there is no tension in the string anymore. M1, if I return to the case which we have there, that M2 is larger than M1, M1 is being accelerated upwards. That's non-negotiable. So it must have gained weight. M2 is being accelerated down. So it must have lost weight. It's just like being in an elevator. There's no difference. They each weigh the same. One loses weight, the other gains weight. They each weigh the same. And so I can make the prediction that if this is M2G, which was its original weight, and this now is the new weight, T, that M2G must be larger than T. M1 gains weight, so T must be larger than M1G. M2 loses weight, so T must be smaller than M2G. That's my prediction. It has to be. And I can show you that with some easy numbers. Let M1 be 1.1 kilograms, and let M2 be 1.25 kilograms. Frictionless system, and the string has a negligible mass. What is the acceleration, A, of the system? I get M2 minus M1, that is 0.15, divided by the sum, which is 2.35, and that is approximately 0.064 G. Approximately 0.064 G. It's about 1/16 of the gravitational acceleration. So it's a very modest acceleration. What is the tension? Well, I substitute my numbers for M1 and M2 in there. You can take for G 10 if you like that. And you will find that the tension equals 1.17 G. And now, look at what I predicted. They both weigh 1.17 G. That's non-negotiable. That is my definition of weight. The tension in both sides is the same. That's my definition of weight. This is their weight. This one had a weight 1.25 G without being accelerated. You see, it has lost weight because it's accelerated down. This one had a weight of 1.1 G. You see, it has gained weight because it's accelerated up. So you see, the whole picture ties together very neatly, and it's important that you look at it that